All right, here we go. Okay, Manuel draws a diagram of a kite, PQRS, with QS as a line of symmetry over the design of a key-shaped fob. He makes a list of conclusions based on the diagram. Which ones are correct? Which ones look to be incorrect? Does PQ look to be perpendicular to, does PR look to be perpendicular to QS? Yes, I would say that one's a yes. Does QP look to be congruent to QR? These two look to be congruent to each other. These two look to be congruent to each other. Does PR bisect QS? Does this bisect this? No. Okay, cuts it in half, cuts it right in the middle. Q between Q and S, that's not the middle. Now, does QS bisect PR? Yeah, that looks like QS bisects PR, but PR does not bisect QS. Does it look like PQR is an equilateral triangle? No, not especially. PQR? PQR is a triangle. Is PSR an isosceles triangle? Yes. Okay, because it has two congruent sides, so that would be a yes. Okay, so what we'll do is learn about various things about kites. Now, the diagonals of a kite, how are they related? What's one thing we learned up top that they probably are? Perpendicular. Okay, these are perpendicular. So if the diagonals of a kite are perpendicular, and let's say this was 6 and this was 8 and this was 12, how long is X? How long is Y? How would we figure that out? Thank you very much, Mia Hine. It's the Pythagorean Theorem. C squared equals A squared plus B squared. So X squared would equal 6 squared plus 8 squared. What's 6 squared? What's 6 squared? What's 8 squared? So X squared equals 100. So X must equal 10. So this is 10. What do you think BC would be? 10. Would Y be 10? So to figure that out, C squared equals A squared plus B squared.
And then it's 64 minus 144. And then you add them together and you get 200 and 208. Then you do just. It's 16. It's 16. Just kidding, I have no idea. It's 16.
I got you.
256 is 16.
Oh, okay. Well, we're 14. It's 14. 12. No, it's not 12. 13. It's gotta be 13.
14.
How many? All right. Shh. It is some irrational number, 14.4 some. It's a non-repeating, non-terminating decimal. It never ends. So, does 16 go into 208 evenly? Somebody take 208 divided by 16. 13 times. So what this is a square root of 16, square root of 13, or 4 square root of 13. The length of this is 4 square root of 13, officially in the math world. What you do, you find a perfect square that goes into there. 16 is a perfect square because it becomes 4. Okay, so 1's a perfect square, 4's a perfect square, 9's a perfect square, 16's a perfect square, 25's a perfect square, and so on. Okay, any number squared is a perfect square. So then we take the square root of the perfect square part. The other part doesn't break down, so that's why it's 4 square root of 13. Okay, that's nice.
No perfect squares on the wall. That's the only reason I remember.
All right. So, officially, the diagonals of a kite are perpendicular. We have now learned that these are perpendicular. Okay? So what we can do is we can figure out certain side lengths because of that, but we won't right here. We just know that the kites are perpendicular. Now, knowing that, how big is angle 1? Amiria? What? Why don't you pay attention to what we're doing, Amiria? I said, how big is angle 1? 90. Why do we know that? Because we've been talking about that for the last 5 minutes, that diagonals of a kite are perpendicular. All right. So if that's 90, then its vertical angle is 90 over here. So how big is angle 2? No, 2 would not be 90.
I didn't see the number. 90 plus 35.
180 minus 90 minus 35 is 55.
Think differently, you know?
About how big do you think 3 is?
I'm not gonna say 5. I have no idea.
3 would be 35. And let's see why.
55 is the same on the other side. That's not right. The 2 is the same on the other side because they're equal.
Okay, why are they equal?
Because they're.
This triangle, hey, shh. This triangle here and this triangle here are congruent. Why are they congruent? Because they each have a hypotenuse that are congruent and a leg that's congruent. So by hypotenuse leg, if this is 35 down here, this is 35 up here. So if this is 55 here, this is 55 here. Okay? Now, does this look like it's 35 right here? No. These angles aren't bisected, but the diagonal does bisect the far angles. So this would be equal to this. So opposite angles are bisected on one set in a kite. So in a kite, the definition of a kite is it is a quadrilateral with 2 pairs of consecutive sides that are congruent. So these are consecutive sides, 2 next to each other. The other 2 pairs of consecutive sides are congruent, but opposite sides are not congruent. Okay? If opposite sides were congruent, then it would be a parallelogram, but it's not a parallelogram, it's a kite. Okay, now we're going to look at trapezoids. Now, to make a trapezoid, to be a trapezoid, you have to have exactly, no more, no less, exactly 1 pair of parallel sides. If it had 2 sets of parallel sides, it'd be a parallelogram. So if it has exactly 1 set of parallel sides, it's a trapezoid. Now, we're going to talk about a special type of trapezoid here called an isosceles trapezoid, where the 2 legs, this is a leg and this is a leg, the 2 legs are congruent. The parallel sides in a trapezoid are called bases. The bases are parallel, but they are not congruent. Here, the legs are congruent. Now, what do we know about base angles in isosceles trapezoids? They are what to each other?
Parallel.
Base angles are parallel to each other?
I don't know.
They are congruent to each other. 60 and 60 are the same. 120 and 120 are the same. Base angles are congruent. What did those 2 angles add up to? What do these 2 add up to? So, consecutive angles that are in between the parallel lines are same side interior angles. They're on the same side of the transversal to the insides of the 2 parallel lines. What do we know about same side interior angles from chapter 3? They're always supplementary. Okay, so trapezoids will have a pair of supplementary angles. Another thing about isosceles trapezoids, the diagonals are going to be congruent. What does congruent mean? They're the same length. So if it's an isosceles trapezoid, which is a special type of trapezoid, if it's an isosceles trapezoid, the diagonals are going to be equal to each other. Nope. So here's a trapezoid. Don't worry about the up and down supports. Here's a trapezoid. Now we're told angle 1 is 138 degrees. So if this is 138 degrees right here, this one here is 138 degrees. What's angle 2? 138. We're looking for angle 2. How big would angle 2 be? We're not dividing by anything, young lady.
Did you look at me?
Yup.
That was Ella. I didn't say that. You said I'm too smart to say that.
Uh-huh.
I don't understand where 2's even at. Is it the side at the bottom or is it the side on the top? Is it the side on the side? But they're not.
It's right here.
Wait, did you say
This is angle 2.
It's not a side.
Angle 2. Angle 2. So 138 and 2 have to add up to what? 180, because they're same side interior angles. So 46, 42 there, Einstein.
8, 9, 10.
180 minus 138.
4, 5, 6, 7, 8, 9, 10, 11.
Okay, this one's for you, Mia. If BD is x plus 3 and AC is 3x minus 11, how are we going to figure out how long the length of BD is? How long is BD if BD is x plus 3 and AC is 3x minus 11? What would you do? Set them equal to each other. Thank you.
Boom goes dynamite. Boom.
Subtract x.
2x plus 11.
Add 11 to each side.
14 divided by 2, which is 7.
What she was doing, Amiria, is not worried about what I was writing out. She was doing all the math in her head all at once.
But then you guys figure out them together.
So, BD is how long? Why is it 10? Put 7 in for X.
I thought I asked for A, B, C, D.
Okay, the last thing that we're doing today is mid-segment of a trapezoid. Mid-segment of a trapezoid. So the mid-segment of the trapezoid is the average of the two bases. So here's a base, here's a base, the parallel sides of the bases. So you add up the two bases and divide by 2, and you get the mid-segment. 4.2. So 4.2 and 10, if you add them up, that's 14.2 divided by 2 is 7.1. So here's a Gucci purse or whatever. Versace? Okay. Thank you. So we're wondering how long this line of jewels is. It's going to be 7.5. So you add up 9 and 6 and divide it by 2 and you get 7.5. Now those are easy ones. Let's say we had something like this. B plus 2, B plus 8, 24. How do we figure out how long the mid-segment from A to B is? B plus 2 plus 24 divided by 2 equals B plus 8. Now, because you're taking the average, you add them up and divide by 2. Now, I've got b's on both sides of my equation, so I can't just divide this all by 2. So what can I do to get rid of my crazy fraction I have on the left side? Multiply everything by 2. If I multiply both sides by 2, the 2's cancel here, and I get b plus 2 plus 24 equals 2b plus 16. Or b plus 26 equals 2b plus 16. So if I subtract b from each side, 26 equals b plus 16, and subtract 16. B equals 10, so how long is AB? 18. AB is 18 long. 12 plus 24 divided by 2 is 18. There you go. Okay? If we want to separate the small dogs from the big dogs, they want to make a parallel fence right in here. How long should the fence be? How long is the fence going to be? Thank you, Ella.
70 plus 120 divided by 2.
Which is 95 feet. So, in summary, kites. Yes, go Mia. In summary, kites, their diagonals are perpendicular. Okay? The one diagonal gets bisected by the other diagonal. And the angles, this angle is congruent to this angle. This angle here is congruent to this angle over here. This angle here is congruent to this angle here. And this angle here is congruent to this angle here. Okay? Quadrilateral, or if we have an isosceles trapezoid, isosceles trapezoids have congruent diagonals and their base angles are congruent. And then same side interior angles are supplementary. So those are some things to remember going into today's assignment. So I think there's only 8 problems on the assignment. It's not super long. It's not super taxing. So I will let you get going.